All right, let's get going. Well, again, welcome everyone. My name is Aaron, and I am a technical account manager on the aerospace team, supporting our aerospace and defense customers here in the U.S. And today I have the pleasure of talking with you all about hex meshing in HyperMesh 2025, which is one of my favorite workflows in HyperMesh for a couple of reasons. For one, it's just particularly satisfying, in my opinion, to see a hex mesh come together, to come to completion. And but for another, it taps into a lot of the different workflows that we have in HyperMesh, like from a meshing standpoint, at least, and leverages all those building blocks together to create a pretty cool mesh in the end. All right, so in the interest of time, I'm going to try to move through this quickly. We could really do an entire series on hex meshing, so I'm going to try and hit some high points today, and on the workflow as well as my preferred tools at least, and then spend most of our time going through a demo that tried to get one that was interesting and complicated enough to be interesting, but also to fit in the time we have today. And then hopefully we'll have a couple minutes at the end for Q&A if you guys have anything you'd like to discuss as well. So on the workflow front, and these are somewhat in order of how I approach a model when I'm going to try to hex mesh something. One of the first things I do is look for symmetry, as well as any features that are repeating throughout the part. So like with this model here, this was just a kind of a dummy part that I created to demo hex meshing a while back, actually. But it's, you often encounter parts like this where there's at least one plane of symmetry. In this case, there's even two planes. So at most, you would have to mesh a quarter of this part. It's not super complicated, but it's, hex meshing this would require a fair number of splits. So it might just be more tedious to do the splits and fine tune the seating for the whole thing versus just doing a quarter of it. You also have these fastener holes around the edge here, and you might want to, if you want to keep those in your mesh, you might want to just create a mesh that you fine tuned and you like around one hole, and then duplicate that and just kind of chunk out around the rest of the holes, so you don't have to redo that pattern everywhere. So when you're doing hex meshing, it's a little more time intensive than just a shell mesh operation, and so it can often be fruitful to take advantage of symmetry and repetitions. The other thing you want to do is remove unnecessary features that are just going to make your life way more complicated than it needs to be. By the same token, you don't want to remove things that are important, but usually, smaller fillets and things, depending on the size of mesh that you're planning to put on your part, you can pull those off pretty easily with the Defeature tool in HyperMesh. I'm not going to spend a lot of time talking about these tools and methods today. I think there's been other sessions where I've gone into more detail on that you can check out. But yeah, just basically know that the Defeature tool is useful, particularly for removing fillets, depending on how clean the fillets were when the CAD designer put them in the first place. HyperMesh can pull them out pretty easy. And if not, you can always resort to deconstructing and reconstructing your solid. So you delete the solid, keep the surfaces, then go in and delete the fillet surfaces or whatever surfaces you're trying to defeature, close back up the solids in those gaps with straight edges. And then once you have a fully enclosed surface, set of surfaces again, you can recreate your solid and move on from there. Also consider whether you want to remove things or just suppressing them would be okay. So we'll see in the demo, like there's a couple of features here in this model that really just need to suppress an edge here or there to keep it from interfering with the mesh too much. All right, the next thing I want to look at is natural flow directions. And this one you have to, it's a little bit different from, shell meshing or other operations where in HyperMesh. So think about it in terms of like a UVW perspective. So what, U and V direction are going to be kind of the in plane directions, and then W is the out of plane, because at its essence, hex meshing is creating a shell mesh on one face of a three-dimensional solid, and then extruding it through, creating elements as it goes. And so you need to think about which direction is going to make the most sense for that to go through. So for something like this, it's very clear. Another way I think about it is, if I toss this on the ground or threw it up in the air, how would it land? You can just kind of have, I find most parts, there's kind of a natural sense of what are the U and V directions versus the W direction. So like I said, for something like this, it's obviously very clear. For something like this, it's a little less clear. You can, there's obviously a length direction, but then, it kind of goes around a corner, and there's almost two pieces here. And so this is the main part that I'm going to demo today. And in this case, if you just split it at this face here, then you have kind of an angle there and a little bit of a bathtub fitting here, and then it becomes, the flow directions become more clear. You also have to encounter things like, this is a very simple model at first glance, but it's actually a pretty complicated problem when it comes to hex meshing, because you have perpendicular features that you have to reconcile. And so from this, and actually I'll just jump into the next page real quick, because flow directions and mappable solids kind of go hand in hand. So if you're not familiar with the terminology, mappable solids is what we refer to in HyperMesh as the foundation of hex meshing, really. And it just specifies, or is a way of categorizing whether solids can be meshed in three directions. Like a simple cube here, you can imagine you could put a mesh on any one of the faces and extrude it through in the other direction without any issues, or just one direction. And so like in this case, you can put a mesh on either one of the circular faces of this truncated cylinder, and then extrude it through the length of the cylinder, but you can't put a mesh on the outer face and try to extrude towards the middle. That wouldn't work. Similarly, if you just add a split line, or if you have adjacent solids, so you have a simple cube still, but there's another solid next to it that has a shared edge that you need to take into account, or it's just dirty geometry, or whatever the case may be, this reduces the mappability. Now we have to put a mesh on this face, so it can, a seed mesh, so it can take into account that scar line there, and then extrude it through in that direction. And it doesn't have to be perfect angles. Something like this is still mappable in three directions. So the color here is the color scheme that you get with the mappable setting. And like I said, with this, you have the challenge of, at this on this half, you're mappable in one direction, which is along the axis of that hole. And on this half, you're mappable in one direction, which is perpendicular to that with this whole direction. And the key to this is you just have to create a transition area that has a regular grid of a mesh, to where it is transitioning the direction from this direction to that direction. All right. Then next up, we have our meshing approach. There's no pretty pictures for this one. I'll try to not get bogged down in the wordiness of this one. But my general approach to meshing, once I've split up the solid, I have nice mappable solids everywhere, I'll run the hex map tool initially just on everything and see what it identifies automatically as the flow through the part. Because even when you have individual solids that are mappable, you still have to, our HyperMesh still has to figure out with different solids connected to each other the proper order that's going to work out to create a successful hex mesh in the end. And so it will go in and identify for each solid that's making up your part what are the appropriate source surfaces and put an initial seed mesh on those faces. And you can take a look at it at that point if you're happy with it. And there's also some tools that you can interactively change seeding and other things similar to the surface mesh tools within the hex map tool. But it's often advantageous to bounce out of hex map and just use the regular surface topology and meshing tools to clean up the seed mesh. And once you have those source surfaces identified, you can adjust that seed mesh all you want, and then come back to the hex map tool, and it will still recognize that those are the source faces and they already have this mesh on them, and then it will just crank through and create the solid elements section by section. And if for some reason you run into problems with a particularly complicated part where when you try it, all the solids appear mappable at first, but HyperMesh is having trouble actually completing the flow through the whole part, just break it down into sections, work it a quarter at a time, a third at a time, and see. You'll usually run into the section that is causing the problem, and that helps to identify what the issue is. Usually it's a surface that has been seeded with a mesh that has a conflict with another seed mesh. And so if you have 4 elements on one surface and then you go across to the other side of the part and you have 3 elements on that same edge that should be linked, you can't create hex elements in between there. And so you just have to clean those up. And then in the event that hex map doesn't get you fully across the finish line, the extrude tool is another good one to take advantage of, which is just a more manual approach to hex meshing, where you take a source mesh and a target mesh or surface, and you specify some guides, which could be the lines or surfaces along the sides or elements, and extrude it. And creating those elements along the way, just one solid at a time. So speaking of tools, these are my weapons of choice when it comes to hex meshing. These are spread out across several different ribbons by default, but as you've seen when we get to the demo, I have all of these just packaged on a custom ribbon that's my hex meshing workflow, so I don't have to bounce back and forth a whole lot, and I can go from tool to tool without changing ribbons and stay more focused, which if you haven't played around with that, it's super easy. I'll show you real quick in the app when we get there. All right, speaking of that, let's jump into the demo, and we're going to skip the video. Let's go over here. All right, so like I said, creating a custom page is super easy. You just hit this plus button. It's named custom by default. You can rename it, and then at that point you can drag and drop whatever tools you want onto that ribbon, and then you can organize them around however you want, put separators in there, and you can also export them as an XML file, which is super handy for yourself as well as for others in your group. For example, if you guys are interested, I'd be happy to share the XML for my hex mesh ribbon here if you don't want to set it up yourself and you think it'd be useful. It makes it super transportable. Okay, so this is the end product here. Let's jump back to all right, so here we just have our solid, and And I'm going to start by breaking this up a little bit, like I said, along this plane, more or less. But I have kept, so this has been defeatured already. I pulled out the small fillets that I was showing in the chart. I did leave a couple of things in smaller edges in here that we can suppress, but I did leave a number of fillets, as you can see, that we do want to capture in our hex mesh, we'll say. And so when you encounter something like this, a good trick for adapting to fillets is, rather than just splitting along a plane that would be this surface, I like to split the fillet, and I do that by splitting the edge first. And if I hold control, I can jump on over to this edge or to that vertex. So I'm going to come across the face where it's flat here, but then come out halfway into the fillet and then jump over here. And that's going to be my splitting plane, so to speak. So to do that, I'm going to split solids with lines. Just grab these. And then for my direction, I'm holding control, and I'm going to grab 3 points to define my vector. It's going the wrong way. I'll flip that. I do want to turn on extend trimmer. If I don't try to extend, it's just going to try to split right around the line. I want to extend it all the way through the distance of that vector. And oh, I need to select my solid that I want to split. All right. So now I'm in 3D topology mode here, which is also useful. I'm going to switch over to Mappable here in a second, though. In 3D topology mode, the yellow surfaces indicate, or faces indicate, shared faces. So those are the ones that we just split, the boundary between the two solids that we have in our model now. But like I said, I'm going to switch over to Mappable so I can get a better read on my progress. Right now, everything's red, which means that nothing is mappable because it's still too complicated. But let's see if we can break down the left half of this to start off with. So I'm just going to hover over the surface there, and that'll snap a plane to that location there. It automatically picks the solid. When you're using the plane method, it automatically picks the solid that the plane is touching, the base point is touching, which is what we want in this case. And so you can see at this point, this has already turned this color, which means that it is mappable in one direction, which is pretty evident. You put a mesh on either of the top or bottom faces here and extrude it through in the other direction. This one is going around this corner here, and so there are a couple of ways we could attack this. We could just suppress this edge, but we still probably don't want to suppress it because it's important to, it's somewhat of an inflection point in the part, and we still want to capture that. So we'll just split it. In this case, I'm going to drag my points. I'll grab that edge there, and then make sure I capture the edge exactly and don't create a sliver surface. I'll make sure that point is there. And now that's split up. All right. So now let's turn our focus to this side over here. And like I said, now that we have the part kind of divided in two, we can just focus on this one. And the flow directions are a little more clear here as well. So first off, I'm gonna chop off this piece and go ahead and accept that. I'm also going to split at the bottom of the pocket here. It's usually a good idea when you have a pocket like that. All right, so we can see there's a little bit of an offset in between the back edge of this pocket and the face here. If those were lined up nicely, it might be a little easier. But actually, in this case, we're going to use our same fillet splitting trick to do a split, or create some edges rather, that we'll use to split this piece. So what I'm working towards here is the bounding line split method. So I want to create lines that go all the way around the perimeter of where I want my split boundary to exist. So if this, again, if this wasn't, offset here, then that could just be a simple rectangle. But in this case, I'm going to make it a little bit warped and include that edge of the pocket as well as half the fillet radius, and you'll see what that does. So we'll switch back to split. Oops. Solids, bounding lines. All right, so for this one, I need to go around and pick the lines. You don't have to have complete bounding lines to use this method. Ooh. Come back. But I find it's more robust and controlled if you do. So I think it's a good practice. All right, I think I got that. So I got my 8 lines, there's my solid, and I do not want extend on in this case because I do want to just split it where the line is. I don't want it to try and extrapolate and do anything crazy, especially since I got a little bit of strange curvature here that I'm trying to capture. Yeah, and it did something a little strange. So let's undo that. And I'm actually going to undo that split. Might have picked something that was just a little bit off there. All right, let's try this split again. Solids. I'm actually just gonna isolate that guy so it's a little easier to pick. Oops, and I want bounding lines. I just hit I to isolate there, by the way. Works with most any selector. So I had an active solid selector with that one solid. Space Mouse is not agreeing with me here. Okay. There we go, much better. All right, so if you look at this edge on, you can see what it did is created a little bit of a funky looking surface there, but that's actually exactly what I wanted. So when we hex mesh this, it's just gonna morph those hex elements automatically into that transition area there. And you can see it turned into mappable for us, which is great. All right, so I'm gonna switch back. I'm gonna use my hide show shortcut A to bring back everything. The blue is happens when you bring back solids that were hidden in the mappable mode. It just means that it hasn't been evaluated whether it's mappable or not. So if you just switch back and forth, you can bring back your mappable full color setting. All right, so let's turn our attention down here. Oh, and I see we have 5 minutes left. So I'm going to speed through a couple of things here on the splitting, and then I'm going to jump ahead cooking show style to the to a fully split solid and show you the meshing part. Really the meat of the operation is in the splitting. So I'm going to split it there, and in this case I'm going to split it here. I also want to grab that one, and then split this one there. And I'm going to do a similar deal where I'm going to use this face as my plane reference and get to it, and then go to the midpoint of this fillet. And oh, I didn't get the right solid. Well, backspace to clear that one out, and then grab those two, which is what I want to split. Or I'm sorry, I don't want that one yet. Okay, so then I would do a similar transition here with bounding lines using that little bit of a humped fillet transition there into a straight edge on the back, just like we did up top. And that would break that up into Mappable. I do a couple more splits here, but like I said, I'm going to jump over to the fully split one, which I don't have open. Just to show you, jump into the meshing workflow. All right, so in this case, like I said, I suppressed a couple of edges that, like this one, is just going to, it's too close to create, or creates an element too small. In this case, it was going off at a little bit of an angle. Here, it's again too close to that vertex for my liking, and so I suppressed it. I also created some washers around the bolt holes. And at this point, we can jump into our meshing workflow. So Control A, select all my solids. I'll leave on auto detect. I do want to make sure that I have quads only set because I want all hex and no pentas. And I think I want 3 units from mesh size here. All right, and just that quickly, it goes through and identifies all of the source surfaces, seedings. It also puts seedings on the, like through the thickness directions that you can update. Like in this case, say I wanted, 4 elements through the thickness everywhere. I can update that, and as I update that, it changes most everywhere. On holes, you have to go do them individually. You can also, like for these 4 holes, you can do a, I got something else. Do a window selection and then just say, I want those all to be 4. And I could, spend more time cleaning up the density, biasing, face editing of these meshes. I could bounce out of here and use more of my normal shell meshing tools. I do have one solid here that I'm not particularly happy with how it came up with this mesh. In this case, I think I would just leave it alone, and I'm going to go ahead and just say hex mesh so you can see that operation and work, and you can see it working through the different solids in the right order. So far, so good. Watching the status bar, and there we go. So we have, let's see, I didn't double check it to see. Yep, it did all hex. Occasionally, even with quads only, you might get a try in there just based on the seating. Sometimes the geometry is impossible to fully quad mesh, so there's one try to make it work. But in this case, it's fully hex mesh. So once you split it up, it's just that easy. And then, like I said, this one is not ideal. I mean, you could, I guess you might be okay with that. I wouldn't be particularly. So I'd do switch, hit S to switch to solid selector, grab that solid, hit E to cross-reference the elements real quick, delete those, and then I would come in and put a freeform mesh here. Oh, I didn't change it to quads, so I'll do that. And then come back to map, and now it will automatically recognize that there is a surface mesh there that I want to take advantage of. And you can see all the seating is even grayed out at this point because the surface mesh is assumed to be fixed constraint, and just remesh that. And now I have a nicer mesh there. All right. So that's hex meshing in a nutshell. We are 1 minute over, but I'm happy to take questions if you guys have any. I don't think I had anything else in the charts in particular to talk about.